Hi everyone. Welcome to 4.1, Intro to Trigonometry. You can see the objectives for the lesson today. We're going to have some introduction and history to trigonometry, introduction to radians. We're going to talk about some coterminal angles in radians and complementary and supplementary. And I'll give some extra credit to anyone who can find the error in this cartoon. Trigonometry is the measurement of angles. It's from the Greek triangle and measure, so it's the measurement using triangles. It's the branch of mathematics that is ancient, as ancient as the Greeks, and it looks at many different applications that we use trigonometry. It's going to be one of the most useful mathematical tools that you will use. You can see that you can use indirect measurement. It's used in astronomy to find the height of mountains. It's used in navigation, light wave refractions. Sound waves are all sinusoidal that follow a sine or a cosine wave. Subatomic particles, planetary orbits and pendulums. Note the triangle, the use of triangles. These actually look like equilateral triangles in the bridge, using bridge supports. Global positioning systems allow you to triangulate positions on the Earth using triangles, triangulation, with a satellite above the Earth. They can be very accurate. Music, I liked this one. It's not completely sinusoidal, but it has a really interesting shape to it. The ancient Greeks either invented or discovered trig, depending on your point of view, and they needed some kind of way to express their study of the stars and of space, so astronomy was the driving force. They started doing this the middle of the 1st century BC and reached its final form by the 2nd century AD. So this is another ancient study, and you can see some tablets and things that were used in that time. Angles, as you know, are measured in either degrees or radians. This may be the first time you've heard the word radian. We're going to explain that in just a second. Most of the time, everybody knows that a circle has 360 degrees. But technically speaking, degrees are not actually numbers. And also we have in degrees 360, so we have very large numbers. Radians, you have much smaller numbers. Radians are more convenient. You only use radians in calculus. And I can tell you that we start with degrees and everybody thinks in degrees at the beginning of the semester, but by the end of the 1st semester and certainly by the end of the year, it will be painful to go back to degrees. You'll be so immersed in radians and thinking in radians. As you know, your graphing calculator has 2 modes, radians and degrees. Probably in geometry class or in algebra 2 when you use trigonometry, your calculator was set to the wrong mode. We'll talk about that again. The radian is the length of an arc of a circle that is the same length as the radius of that circle. Okay, that presupposes that you know what all of these pieces are. Okay, we do know that the center of a circle, which you can see down here, the center, right, of the circle, and then if you have a chord that goes from the center to a point on the outside of the circle, we'll call this point P. This, of course, is the radius of the circle. This point over here, from C to this point right up here, we'll call it Q. This is also a radius. But what you'll notice is that the radius, it goes from Q through the center all the way to the other side. This is a diameter. And we all know that 2 radii make up a diameter. And 1 radius is just a diameter divided into 2 pieces. Okay, so this piece right here, this piece from Q to P is called an arc. It's not all the way around the circle, it's just around the circle from Q to P, and it's an arc with a C, not a K. Arc is like Noah and the. This is an angle. Sometimes we call this theta. Theta is just a Greek letter that we use to denote an angle. In geometry class, you might have called it QCP, but it's still a central angle with its vertex on the center. And so this is an angle measured in degrees or in radians. Okay, so a radian, if you're, well, a circumference, if you're talking about all the way around a circle, that would be the circumference or the perimeter of a circle, right? Then this would be C equals 2 pi r. Now, some of you, if you get this wrong, you usually say pi r squared. That's really the area of a circle, but all the way around. So if you had an arc that went all the way around, this angle theta would be 360 degrees all the way around. And this arc would be all 2 pi times the length of the radius, whatever the length of the radius is. All right. So here over here, I have this other circle, which is kind of handy to have. So let's talk about what is a radian. Well, if this length right here, let's say this is just 1. This is the length of the radius, right? R equals 1. Then if you took this piece, like a piece of string, same length, and you started here, and you laid it on the circle in a curve, which is possible if you had a piece of string, this would also be 1 long, right? So then this angle, instead of being in degrees, would be 1 radian. Okay, let's look at this next page because you can see it the same way. This length, the length of the radius and the length of the arc are the same length. So that means that the angle right here, this central angle, is going to be measured in 1 radian. So 1 radian is 180 degrees divided by pi, which is about 57.296 degrees. So this 1 radian is equal to 57.296 degrees. So just guessing, how many radians do you think there are in a circle? Think about it a second. Well, let's go back to our circle. Let's say that the the radius is equal to 1. Then all the way around the circle would be 2 times pi times the radius, or 2 pi. So what you find then is that radians, there are about 2 times 3.14, or there are approximately 6.28 radians in a circle. Okay. So once again, we have a unit circle, or in other words, the radius of each of these circles is 1. All right. And so what we do is we start here. We have, if we had this radius is 1, right? Then if we had an angle that went all the way to here, this would be how many degrees if we start like this? Well, that looks like 90. Doesn't it look like a right angle? So this is 90 degrees. This over here, straight angle, 180 degrees. Add 90 more and you get 270. Add 90 more and you get 360 degrees. 0 or 360 depending on whether you went all the way around. Well, radians are the same thing, right? If you start over here, I'm going to have 0. If I don't move anywhere, I'm going to have 0 radians. And then what's all the way around? Well, remember that the radius of this circle is 1. The circumference all the way around is 2 pi times 1. All right, so then this way is halfway around. Well, how many radians is that? 2 pi divided by 2 is just pi. So that would mean that pi and 180 are the same length around, one in degrees, the other in radians. Okay, over here we have pi over 2. This is 3 pi over 2, and back to 2 pi. These are called quadrantal angles. So a unit circle with a radius of 1 unit is going to be set up this way for degrees and this way for radians. Okay, on this, what I want you to do is to copy the following fractions in order from smallest to largest in your notes. You will have 1 minute. Go. You got about 30 seconds. Okay, I'm going to pause it here for a second because a minute's going by very quickly. But I want you to think about something. There's a way to organize this so that you can do this much more easily. Have you figured out what it is? What's your plan? Wow, that was loud. There you go. Back to the unit circle. Do these things look familiar? How did you do? What's the difference between these numbers and the numbers that I had on the previous screen? Can you tell? Write down your answer on your composition notebook. I'm going to be asking you when I see you next. Now the rest of this lesson is going to go back to complementary, supplementary, coterminal, and using more and more of the unit circle. So your in-class activities are going to require you to know these things. So if you need to, go back, rewatch this part again, and I'll see you in class. Bye now.